Fun Sock Friday, the 30th of October, almost done with the month. Algebra 1, SWA students will be able to plot points, functions, and relations, section 4.1. So this is chapter 4a, okay? You might be wondering, why is it called 4a? Well, because we have a 4b we'll do later, okay? So I split chapter 4 into two chapters, okay, in two different units. So this is unit 4a. It's kind of, it's like half of, or really closer to 2/3 of chapter 4, and then chapter 4b will be kind of like the last third, but it's really long, so I split it up for you guys, okay?
Is it one chapter? This is half a chapter?
This is like 2/3 of a chapter. Why do you think I split it up? Okay? That's not even close to this, okay? My name is Mr. Kossel.
Are you sure?
Me llamo es Senor Kossel. Okay, so go and write your name down. The coordinate plane. There's some things we know about the coordinate plane. What's something we know about this coordinate plane, guys? Okay, Haven. There's 4 quadrants, okay? Courtney.
There's a y and an x axis.
Okay, there's a y and x axis. Y-axis, x-axis, or the axes for plural. Okay, which one's the x-axis?
The bottom one.
Okay, the one that runs left to right. Show me with your hands right now which way the x-axis goes. Show me with your arms, okay? Which way the x-axis goes, okay? Very good. So that is the x-axis. I would encourage you guys to label that real quick. Show me with your hands and arms which way the y-axis goes, okay? Very good. It goes up and down, okay? That's vertical. One way one of my TA likes to remember it is you can make this, the y-axis into a y. Okay, I've never heard of that before, but apparently he likes it. I'm like, oh, that's pretty neat. What's a special point on this graph? 0, 0. What's 0, 0 called, guys? It's called the origin. Very good.
It made me go upstairs. So, can you write inside it?
If you want, or you can also just kind of draw an arrow and go like...
You can put stuff numbers in.
Oh, we're not going to plot on this one, no. This one we're not plotting on. We'll plot on the next one, which is why I have it listed again. But we're not going to plot on this one. This one's just for labeling right now, okay? And we did have those quadrants like Haven talked about. Does anyone know the names of the quadrants or the numbers of them? Okay, Isaac?
The Roman numerals.
Okay, they're Roman numerals, and we do the first 4. Does anyone know which one quadrant 1 is? Okay, Abby?
Is it the top left?
That's not the top left, nope. Top right.
It's an origin.
Top right is the quadrant 1. Does anyone know which one quadrant 2 is? Ellie?
Wait. The one below that?
Not quite.
No. I know.
Okay.
It's the one on this side.
The top left is quadrant 2. Okay, it goes counterclockwise from there. So where would quadrant 3 be?
Under that.
Under quadrant 2.
Oh my goodness.
Where would quadrant 4 be then? The last one, okay? Okay, quadrant 1, 2, 3, and 4. We start at the top right, where both x and y are positive, and then we go around from there. Okay? So, for the x-axis, which way is positive? If this is 0, which way is positive? To the right. Very good. Just like a number line, right? We just got done doing some number lines in our last chapter a bit. And so left is negative. For the y-axis, which way is positive? Up. Very good. Positive is going up. Negative is going to be going down, okay? Okay, so that was section B of this. Section A. Section B, talking about ordered pairs. Each point on the coordinate plane has an ordered pair. Ordered pairs are written x, comma, y. Okay, we have the x coordinate, then the y coordinate. It's alphabetical. X comes before y in the alphabet. X comes before y in our coordinate. I want us to graph these following points, A, B, C, and D, okay? And they each have the coordinates next to them. And go ahead and graph one and label it. Go ahead and do that now on your sheet, okay? So go ahead and graph that.
How do we label it?
Okay, so just put the letter. So let's say for point A, where would I go for? It says 4, 2. Where do I go for? To the right. Where do I go to? Up. So I'd put it at 4, 2, and I'm going to put a capital A next to it. That's what I mean by labeling it. Great question. So go ahead and do points B, C, and D.
It's just too small for me to use numbers, so I use colors.
Okay. Okay, for point B, where would I go? Who can raise your hand to help me out with point B? Okay, Jaden.
Just 5 down.
Yeah, just 5 down. I'll go any left to right because the x value is 0. So I go 5 down because it's 0, comma, negative 5, and that's my point B. Ooh, that's not what I meant to do. There we go. Who can help me out with point C? Okay. Go ahead, Courtney.
You go left on the X over 4.
Okay.
You go up 9.
Left 4, up 9. Let me count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Who can help me out with point D? Negative 3, comma, negative 7. Go ahead, Emily.
You go left 3, down 7.
Left 3, down 7.
I got the distraction too.
Okay. Yeah, if you hold your breath, it can help. Drinking water can help.
Well, you can lay down.
Okay. Questions on those? Questions on where those go? So the biggest thing I see, guys, on this is where people make mistakes on graphing points. Okay, is switching around the X and the Y. Okay, a lot of times they'll go up and down first, and then left and right. But you always do the left and right first for the point, and then the up or down. Okay, because it's X, comma, Y, and X deals with the left and right. Questions on that? Okay, we're on part C already. Okay, we're blazing through this. A relation. Relation is a fancy word in math for a set of ordered pairs. A relation is a set of ordered pairs. Okay? Things are related, that means they go together, right? Okay? So, have we seen these braces before? Okay, we just got done doing a lot of that too, okay? So, this is saying this is a set. This is the set of numbers that go together. And inside the set, we have 4 ordered pairs. We have the ordered pair negative 3, comma 3. Then we have comma. Negative 1, comma, negative 2 is the next ordered pair. Comma to tell us the next thing in the list. 1, comma 1 is the next ordered pair inside parentheses. And then 1, comma 3 is the last ordered pair in this set. Courtney?
Are we doing set notation for this then?
Not going to be doing a ton of set notation here. We're going to be doing the braces a little bit, but it won't be nearly as much as last chapter. Yep, great question, okay? But this is familiar to us and how this looks because we've been doing that. So another set we have is called the domain. Domain is a more specific type of set. Domain is the set of all the first coordinates of a relation. Okay? So it's a set of all the first coordinates in a relation. Which one's the first coordinate in each of these ordered pairs? The x. Okay? So the x. So the x values. So domain is all the x values. And notice this note here, guys. This little sub-bullet. Okay? Because it goes inside of this bullet, underneath and inside. Okay? You write these from smallest to largest, writing each value once. We've been practicing writing smallest to largest anyway, right? Yeah. It's handy to have an ordered list from the smallest to largest because we can read it faster, okay? And we're going to write each value only once. So for this, we're not concerned if a value repeats itself. We only want to see what values occur at all. So if I were to say the domain here, I would put a capital D, and I'd do a colon. What do we think that D might stand for? Domain. And then I'm going to start my brace like I'm doing set notation, okay? And then I'm going to list all the x values of these from least to greatest. But we don't have to do any such that or any of that. So what's my lowest x value? Negative 3. What's my next x value? Negative 1. And what's my next x value? 1. Do I need to put 1 again? No, because we don't repeat. And then I'm going to close my notation. Okay, and we say, hey, the domain, all the different x values we see are negative 3, negative 1, and 1. Those are the different x values we see. We see 1 twice, but we're not concerned about that right here. We're just concerned that we see it at all. Next, we have the range. The range is the set of all the second coordinates of the relation. So which values do you think these are going to be? The y values. Very good. And just like with the domain, we write these from smallest to largest, each value only once. So what letter do we think we might use for the range? The y. Just kidding. R. Very good, Abby. Okay, R. Okay, so we're going to put our brace. And who can help me order these from least to greatest? Okay, go ahead, Emily. 1, 2, 3. And even though we see 3 twice, we aren't going to write it again. So you do R colon for range. If you want to write out the word range, you can. Traditionally, we just shorten it to R, though. Okay, but if you want to write out domain and range, you can. We just normally shorten it to D and R. Okay. Questions on this? Okay, let's go and flip the page. Okay. We're on letter D. Okay, it says C, but it's letter D, really. Might be. Okay, it says C on all of our notes, but it's really letter D.
Letter F, so like,
Yeah. We're going pretty quickly through this, okay? So we have 4 different ways we can show relations. So we just saw one way was with ordered pairs, okay? So that was one way we just saw was making it with ordered pairs, okay? And now really, excuse me, this is a typo. That second brace here really should be a parenthesis, okay? The second brace there should be a parenthesis. I think that's messed up on your guys as well, okay? So heads up on that. What was that? Oh my goodness, and I forgot to close the brace. My goodness, multiple typos. I apologize, okay? Profusely, okay? I should add. So we have a set of ordered pairs. That's a relation, okay? These go together. Now we can also make it a table, an XY table. Have you guys made tables of data in science before? Yes. Okay, this is kind of like that, okay? So we're going to put our X values on the left, and we're going to put our Y values on the right, and we label the columns X and Y. Now we're going to want to put our X values from least to greatest, okay? So what's our lowest X value of these same 3? Okay, -3. And then what's our next X value? 1 and then 7. Now the Y values. You may be wondering, how do we put those? Do we put those least to greatest as well? Raquel, Sarah? We actually don't, okay? We actually match up with the X value. So what Y value goes with -3? 2. So we're going to put that next to it. Okay, because we want to still keep the ordered pair together. Okay, we still want to keep that ordered pair, that coordinate together. But we just want to organize some way. So we're going to choose to organize it by the X's. It's kind of like when you organize people by last name. Okay, are all the first names going to be in the same order?
Yeah.
If we alphabetize by last name, are all the first names going to be in the right order? No, but it's not like we're going to mix up the first names, okay? It's not like we're going to change first names just because we're ordering by last name. Does that make sense? Okay. So what would go with 1? 4. What would go with 7? -9. Very good. So we're not concerned that the Y's are not in numerical order, but we want the X's least to greatest, okay? Now, if we were to have a tie, let's say we have 2 X values that are the same, we would use a tiebreaker as whichever Y is lower. We can also graph it, so let's go ahead and graph these 3 points, 1, 4, -3, 2, and 7, -9. So 1, 4 would be 1 to the right, 4 up. -3, 2 would be 3 to the left, and 2 up. And 7, -9 would be 7 to the right, and 9 down. Questions on those 3?
Do we start ABC?
No, so these actually don't have names, so we're not going to name them. So we only are going to label them with the letters if they have already labels given. Great question, Elijah. Neat shirt. The last one we're going to learn is a mapping diagram, okay? So we have the set of ordered pairs, we have a table, we have a graph. Now we're going to do the mapping diagram. This one's probably completely new to us. We're going to put all of our X's on the left, we're going to put all of the Y's on the right. Okay? So domain on the left, range on the right. Because the domain is the X values, range is Y values. Now these, we're going to do the same rules as we did for the domain and range. For the domain and range, we did them smallest to largest, and we didn't repeat. So we're going to do the same thing. So how are my X values going to be ordered in here? -3, 1, 7. Okay. Now my Y values on this one, unlike the table, the Y values go from least to greatest as well. So who can help me out with that? -9, 2, and 4. There we go. Now, right now, would you know which X goes with which Y if you just looked at the mapping diagram? No, okay? So here's what we're going to do to help with that. We're going to draw arrows, okay? So -3 goes to which point? 2. So I'm going to draw an arrow from -3 to 2 to show, hey, -3 goes to 2. What does 1 go with? 4. So I'm going to draw an arrow from 1 to 4. Saying, hey, 1 goes to 4. Okay, bless you must rain down after lest we forget. And then 7 goes with negative 9. So I'm going to draw an arrow from 7 to negative 9. Okay, so this one we end up putting the domain on the left, range on the right, just like we did domain and range. No repeats, smallest to largest. And then we draw arrows so that way we know the order. Questions on those? Okay, so we're going to practice using these, okay?
I have a question.
Oh, yeah, sorry.
Not on that. Okay, yeah, this one. So what happens when there's 2 3s, like on the X?
Yep. So, yeah, so great question. So on the table, you would write 3 twice. On the mapping diagram, you would have 2 arrows coming from the 3. Because you aren't going to repeat them. Very good. Okay? So I want you guys to try and take this ordered set of ordered pairs in number 1, and let's make a table, a graph, and a mapping diagram if you can.
So we can just make a table off the side.
Yep, you can just make a table anywhere. And if you guys are really feeling feisty about this one, you can also do the domain and the range.
Yeah,
Do we have to?
So for the table, can somebody help me and tell me what the table would look like? Haven, go ahead.
-1,
Okay.
3, 3, and 4.
Okay, so going down on the x, -1, 3, 3, and 4, okay? Hey, you want to help me with the y's then?
-6,
Okay.
-4, 2, and -6.
Very good. So the x's go least to greatest, and we do repeat them, okay? And then the y's just match up with the x's. Now, notice Elijah did a good job putting that -3, -4 before the 3, 2, okay? Because when there's a tie with the x's, we go tie break it with the y. Questions on the table? Okay, so if we were to graph these now, -1, -6 goes 1 to the right, 6 down. Okay, 3, -4 goes 3 to the right, 4 down. 3, 2 goes 3 to the right, 2 up. And then 4, -6 goes 4 to the right, 6 down. The mapping diagram, can anyone help me fill in the x's on the mapping diagram? Okay, go ahead, Abby Dasher.
-1,
Yep.
3, and 4.
-1, 3, and 4. We don't repeat the 3. Very good, okay. Then help me with the y on the mapping diagram. Okay, Abby Simmonsma.
-6, -4, 2.
Very good. -6, -4, 2, release to greatest, only repeating once. So, who can tell me what arrow or arrows come from -1? Where does it go? Emily?
-1 goes to -6.
Okay. Want to keep going, Emily?
3 goes to -4. 4 goes to -6. And 3 also goes to 2.
And 3 also goes to 2. Very good. So -6 has 2 arrows going to it, and 3 has 2 arrows coming from it. Okay? Questions on the mapping diagram at all? Okay, and then last but not least, the domain and the range, okay? Someone want to help me with the domain here. Okay, go ahead, Abby.
-1, 3, and 4.
Very good. -1, 3, and 4. We don't repeat them. It's basically just what the mapping diagram is on the left, right?
Oh, right.
Okay. And you have the D colon and then the braces. Who can help me with the range here? Okay, go ahead, Emily.
-6, 4, and 2.
-6, 4, -4, and 2. Okay, bless you, bless rains down after bless you forget. Any questions on this, guys?
Will you slow down and tell us what you're saying? Like, what'd you say?
Oh, bless you, and bless the rains down in Africa, lest we forget. Lest means that we should not or that we don't forget. So saying, oh, let's make sure to bless the rains down in Africa because we shouldn't forget that.
Why Africa?
Because that song's a banger. I mean, you can be wrong, okay? Give me a thumbs up if you're feeling good about these. Thumbs down if you're not, okay? Be honest with me. Okay, Brady?
Oh, dude, completely wrong. So,
Is that a -4?
It is a -4. Okay? Alrighty. We're going to skip number 2. Okay, cool.
actually, math one.
Okay?
Okay.
We're skipping it. Okay?
Is that for a cup?
Oh, I skipped a part, didn't I?
Yeah.
Oh, I missed a part. Okay.
Yeah, we're only on D.
All right. So letter D, really it's E because we had two C's on accident. Okay. Functions. So there's a more specific type of relation. Okay. So a function is a blank. A function is a relation in which each element of the domain is paired with exactly one element of the range. So it's like you have the category relation, and then a more specific category is function. Just like you guys are all high schoolers, right?
Yeah.
But more specifically, you guys are all freshmen. Now, does that mean all freshmen are high schoolers?
Yes.
Okay, yeah. But does that mean all high schoolers are freshmen? No, okay? So it goes one way, but not the other. So all functions are relations, but not all relations are functions. Okay? Have you guys ever heard of like every square is a rectangle, but not every rectangle is a square? Okay, same idea, okay? So every function is a relation, not every relation is a function, okay? It's a more specific type of it.
Mind blown.
Okay? Okay? So it says it's a relation in which each element of the domain. Element means it's just a part of it, domain. So what things are part of the domain? Which values were those? The x values. So when it says each element of the domain, I want us just to put the x values. Okay, that's going to make this definition simpler for us. When it says each element of the domain, that just means the x values. Is paired with or goes with exactly one element of the range. So element of the range, what would that be talking about? The y values. So what this is saying is that each and every x value has exactly one y value. No more, no less. There's no x value with 2 y values. There's no x value with 3 y values. There's no x value with 0 y values. Every x value has one y value. Here's another way to think of a function, okay? It's a more specific type of relation. You guys know what a vending machine is, right? You go up to it, you put your money in, you type in your code, you get out the item. Okay? So, let's think we have a vending machine, okay? This vending machine is our function. And on this vending machine, I go up, I put my money in, and I push E4 because I see a Butterfinger in that slot and I want it. Okay, so I push E4, I get my Butterfinger out. Okay? So if I push E4, that's my X. Okay? I'm going to put that in. I'm going to get out my Butterfinger. That is my Y. So you put in your X, you get out your Y. That's how a function works, okay? The X goes in, the Y comes out. And now, if I push a different button, am I likely to get something different? Mm-hmm. Yeah, if I push maybe, I don't know, C2, I'm going to get Pop-Tarts.
Have you
Okay.
ever pushed the wrong number on accident?
No, that'd be tragic.
The disappointment is.
Oh, man. Now, could you imagine if you had a vending machine, though, and you pushed E4, and it says E4, but there's 2 different candies at E4, and you don't know which one you're going to get? Could you imagine that happening?
It's called a surprise.
No, that'd be horrible, wouldn't it? Okay, what if they had a candy you really like and a candy you hate? And you don't know which one you're going to get, okay? That is not what a function is, okay? So that would be like you have one input, okay, E4, going to 2 different candies. That'd be like one X going to 2 different Ys. That doesn't happen, okay? That's not a function. It's still a relation, but it's not a function, just like it's not a vending machine, okay? But now sometimes if a candy's really popular or something like that, will you see it at multiple spots? Yeah, that's okay, because each spot has its own code. So if I push an E4, I get Butterfinger. If I push E5, I can get a Butterfinger as well. But if I push E4, it's not like I'm getting a coin flip and randomly getting 1 of 2 candies, okay? That's not what happens, okay? Haven.
Can we be real for a second?
Okay.
Favorite candy.
Probably Butterfinger. I love Butterfinger.
Dude, Butterfingers
Why do you think I
are
said it
so
like 5 times, dude?
underrated. They're so good.
They're so good. Okay, Butterfinger, Twix are up there.
Eat it and
No,
then.
Twix are not bad.
I love the caramel M&Ms or the peanut butter M&Ms. Fudge, I never had those.
Are you serious?
Oh, yeah, I'm serious. I've never had Fudge Brownie. Cookies and cream Hershey's.
The zombie.
It's too sweet. You can't
You're
eat
gross.
You can't eat a whole one, like one.
Okay.
They're too sweet.
Okay. All right. So we're going to determine if these relations are functions. So if a relation is a function, each x goes to exactly one y. The vending machine is going to work properly. Alice, can you put it away? Thank you, okay? So in this relation, we have the x's 3, 4, 6, and 7. Do we see any of these x's going to multiple y's? Yes, we don't see it. So yes, it is a function.
Oh, function. I'm not a function.
So is it a function? Our answer is yes.
Wait, so if it doesn't, what? Then it is?
So each x goes to,
Oh, quick, you write that down?
I would encourage it, exactly 1 y. Each x goes to exactly 1 y. 3 goes to 2, 4 goes to 5, so on and so forth. It's not like 3 goes to both 2 and 5. 3 only goes to 2. A different thing goes to 5.
Wait, so it's a function if there's not a repeating number?
For the x. We'll talk about that though. Okay, because you can have a candy in 2 slots. Okay, and that's okay.
That doesn't make
Okay, we'll talk about it. Now, if we have this mapping diagram on the right, okay, and I have -3, -3 and 0 both have arrows coming from them, and 4 has an arrow coming from them.
Oh, we just make it random numbers.
I'm using these specifically,
No, this is.
but we're just filling these in. Like, they aren't there, but I'm using these specifically.
This is a function, right?
Okay? Let's look at it. So if I put in -3, I'm going to get a Butterfinger. If I put in 0, I'm getting Butterfinger because it's the same thing. But if I put in 4, I'm getting Pop-Tarts. Is that an okay vending machine? Yes, you can push multiple buttons to get the same candy because it can be in 2 different slots. Okay?
But if you push this, then you get those. Like if you were to get like 1x, but you could get either -3 or 0, then that's not a function.
Correct. Yep. So this one is a function. So yes. And your reasoning again could be the same thing if you wanted to put it. Okay? I think it'll make more sense once we're done with all 4 of them. Okay? So let's look at number 3. 2, -7, -3, 3, 2, 5, 7, -9. Now we might notice that this table's out of order. Okay, right? This table's out of order. -3, 3 really should be at the top. Okay? Do we see an x going to multiple y's? 2 goes to -7. 2 also goes to 5. So that's like putting in the vending machine. Okay? You type in E4. Okay? And you could get out -7. You could get out Butterfinger. Or you can get out 5. You can get out some candy that's absolutely trash, like an Almond Joy, because coconut's terrible. Okay? Don't even at me. Okay? So that would be like the bad vending machine. So this one is not a function.
Oh.
And our reasoning why, okay, because I want us to understand why, okay, is that 2 repeats. Because an x repeats, it's not a function. If the y's repeat, that's okay, like on number 2. It's okay for -3 to go to 1 and 0 to go to 1. But it's not okay for 2 to go to 2 different numbers. It's not okay for one input to have multiple outputs. That's a guessing game which one you're going to get. We don't want a guessing game, okay? We want a sure thing. I'm going to put this in. I'm going to get this out. Okay? So when the x repeats, not a function. Don't blurt. I want you to write down what you're thinking on number 4.
Here's my explanation.
I would encourage it. That's my way of saying yes nicely. Yep, I want you to write down 4. You don't have to raise your hand when you're done. Not this time. Thank you, though. Okay? Anyone want to share with me what they're thinking? Okay, Haven.
Function.
Okay, Haven, you're thinking it's a function. Why do you think it's a function, Haven?
No repeat.
No repeats. I'm actually going to disagree with you. Brady, what are you thinking?
Not a function. 2 repeat.
2 repeats?
Yeah.
I don't think 2 repeats, but what does repeat?
No, I'm saying 2 of them repeat.
Oh, 2 of them repeat, okay. What do we see repeating, though? 3, okay, so 2 of them have the same thing. So one thing's repeating, but we see it twice, is that what you're saying?
Yeah.
Okay, so 3 repeats. Or you could also say, if you wanted, you don't have to write this down, but you could also say 3 goes to 2 and 1. It's not supposed to go to both. Okay, but right now, you plug in 3, you can get 2 or 1 out. You don't know. It's a guessing game, okay? Not a function. That's not a good vending machine, okay? You're not going to put in E4 and hope to get Butterfinger. You're going to put in E4 and you're going to get that Butterfinger because you don't want that Almond Joy.
I want the
Okay?
Almond Joy.
You don't want the Almond Joy. Almond Joy is trash.
No.
Okay? Hopefully that helps us to kind of understand that a little bit better. How are we feeling better about that with after those 4 examples than we were after like 1 example?
Yeah.
Okay. Continuing on. Okay? If the y in an equation has an exponent of 1, then it is a function. So we learned about exponents before, right? Okay? So on number 1, if we don't see an exponent on a number or a variable, what is the assumed exponent? 1. 1 is secretly there. Secretly y to the power of 1. Okay? So this is a function. Because y is to the power of 1. We'll talk more about these later. Now, if there's no y, or it's y squared, aka y has anything other than an exponent of 1, it's not going to be a function. So number 3, actually, excuse me, go to number 2 on the bottom. I have these in a weird order, don't I? Go to number 2 on the bottom. What's the exponent on y? 2. On number 2, what's the exponent on y? The exponent on y is 2. You're taking coefficient. The exponent is 2. So is this a function?
Yes. It's not. No. Oh, no.
If the y has an exponent of 1, it's a function. If not, not a function. So on number 3, top right corner, that's a function. But wait, the x has an exponent of 2. Doesn't matter. It's whether the y has an exponent of 1 or not. So what are we thinking on number 4 then? Jaden? Yeah, so on these 4, we're just saying, hey, another way to tell if an equation is a function is what the exponent on y is. So if the exponent on y is a 1, so the exponent's a 1, exponent's a 1, exponent's a 2. If the exponent's 1, it's a function. If it's not a function. And we're going to use this more later. We're just learning this kind of as a fact right now, and it's going to be utilized more in the future. Does that help at all or no? Okay. Ellie. It's not the same for x, because if we look at number 3, x is being squared, but it's still a function. So we're not necessarily concerned with the power of x. We're actually just concerned with the power of y. Great question. I get you. So Jade, what are you thinking for number 4? Is it a function or not a function? It is a function because the power of y is 1. Okay? Questions on that? Okay? We're almost through them. Let's go to section E, aka section F, because they're really all 1 letter off. Okay? Nice. Okay, well, hey, let me help you guys understand this even more, okay? The vertical line test. Okay? This is on the bottom of the previous page. Okay? So the vertical line test. Which way does a vertical line go? Show me with your hands. Okay? It goes up and down. Vertical line goes up and down. Okay? Think of a vertical jump. If you're doing a vertical jump like for sports, which way are you jumping? Up. Okay? One way to keep these straight, horizontal. Which way does horizontal go? Okay? Left and right. Okay? Side to side. Okay? Think about the horizon. Yep, think about the horizon. The horizon is where the sky meets the ground. What way does the horizon run, guys? Left to right. It doesn't run up and down, okay? Doesn't run up and down, Eli. It runs left and right, okay? That's the way the horizon runs, so that's horizontal. Okay? What did you say? If you turn your head. Okay? So vertical line test, we're going to be drawing vertical lines straight up and down. If any vertical line passes through more than 1 point, it is not a function. So this is for graphs. This is if you have it graphed out. And if you can draw a vertical line and it hits more than 1 point, it's not a function. If it hits 1 or 0 points, it's a function. Okay? Jaden? Yeah, that's what Abby was saying. Yeah, which is good. So, this first one, do we think this is a function? No, but what? If I draw a vertical line here, it only hits 1 point.
But if you draw a diagonal,
But if I draw it literally anywhere else, it hits more than 1, doesn't it? So this one is not a function. I had you guys all worried, didn't I? Okay. This is not a function. And your explanation could be that it fails the vertical line test. Or we could say it hits more than 1 point or touches more than 1 point. Okay? Does that make sense? Okay, okay. What part confuses you?
Like, do we have to put the vertical line?
So we're saying any vertical line passes through. So you just keep drawing vertical lines, Hayden. Okay, you keep drawing them. And if any single one of them hits more than 1 point, not a function. If every single one of them hits 1 or 0, it's a function. That makes sense? Okay?
That's really it.
Yeah, that's really it.
Oh, yeah.
Okay, let's try number 2 on your own. Don't blurt. Number 2 on your own. And if it's not, I want a quick explanation. If it's not a function, I want a quick explanation. Something along the lines of maybe it fails a vertical line test, or it hits more than 1 point, or something like that. Okay. All right. Yes. I was trying to get the point across. Okay, Eli, what are you thinking? Not a function. But wait, if I draw one here and here, I'm good. But what about the middle? All of a sudden, I'm hitting 3 different points. So since this is not a function, what's our explanation, guys? What could be an explanation?
Fails vertical line.
Okay. I heard touches multiple points. I heard fails vertical line test. I heard touches vertical points like first by like half a second. Too much to write. Okay, let's go ahead and try this third one on your own. If it's not a function, I need an explanation. If it is a function, I don't need an explanation. You don't have to. I'm just walking around right now. I'm just strolling. All right. Ava, what are you thinking? It is a function. There's nowhere on this graph that if we draw a vertical line, it's going to hit more than 1 point. Now, there might be a spot where it hits 0, but is that more than 1? No. Okay, so it's still a function. Question on that? Okay. I'm just drawing dashed ones. I don't know why. Just to show to you that's not normal lines. Okay, that is true. Okay, Jaden.
It's like completely horizontal. That would not be a function, right?
Great question. So what about if we had a completely horizontal one is what Jaden was talking about. So this is our graph now. And I'm going to have this on the graph. Completely horizontal line. Okay, well, if I start drawing vertical lines, is it going to hit more than 1 point?
No, I meant like the other way.
Oh, completely vertical.
Yeah, I meant vertical.
Okay. So now Jaden's saying, okay, wait, what if we had this down here at the bottom, or excuse me, not do the bottom right. Let's do the left side. So this is our graph again, and now we have this line. Is that a function?
No.
Okay, over here it passes, but right here, it's hitting a ton of points, isn't it? Okay, so that one's not a function. That's a tricky one. Good question. Okay, any questions on this besides what's been asked? Continuing on. Okay, last section F, but it's really section G because we're 1 letter off. I told you. Okay, y'all need to trust me. Okay, substituting values. I know you guys have trust issues with math teachers. I'm trying to work on that. Okay. Trying to work on that. Help you guys out. Help you guys trust again. Okay? I'm not gonna leave you, okay? I promise. That's what the last one says. I know, but I'm actually not. Okay?
One of our math teachers will have to move to like Hawaii or something.
Yeah, what?
If your dog has a drink in Hollywood, you have to move to Hollywood because your dog's not forgetting that.
I don't know if my dog will be able to communicate that to me. Jaden. Yes. Oh, yes. Okay. Substituting values. Okay, what does it mean to substitute in general?
Put something in for something.
You put something in for something else. So in sports, where do we see substitutions? In sports.
In football.
Okay, what?
In every single sport.
In most sports, okay, what? What'd you say? No, what'd you say?
I said when someone gets
Okay, if someone gets hurt,
If someone's poorly.
if someone's playing poorly, okay, maybe if you're just trying to get a fresh look at something, okay, maybe the coach is just trying to spark something new, okay. So there's lots of different times we substitutions, okay, or maybe in band, let's say maybe someone's sick, okay, well we need you to take their chair, okay, in a concert band or march band, hey, we need you to fill in their spot, or we're gonna have an empty spot today, okay, that's not good, okay. So substituting. Now, let me ask you this, okay. So got some softball players in here, right? Okay. So am I gonna take my catcher and then put a catcher in at third base?
I mean, some catchers play third.
If they play but let's just say they just play catcher. I'm gonna take my catcher and put him at third base?
No.
Probably not. Okay, probably won't go too well. Okay, football. Okay, Brady, what position do you play?
Lineman.
Lineman. Okay, Brady. Am I gonna take you and put you in at quarterback?
No.
Probably not. Okay. Am I gonna take a quarterback and put him in at the O-line?
I trust Brady.
Probably not. Okay, we're probably not going to do that. Okay, we're going to put him in for their position. I'm going to put a lineman in at lineman. I'm going to put a catcher in at catcher. I'm going to put a third baseman in at third base. Okay, volleyball players. I'm going to take a defensive specialist and put him in an outside hitter. Probably not. Okay,
Specialists are short.
exactly. Okay, I'm probably not going to do that. Okay, band. Am I going to take someone who plays the trumpet and put him in and saying, hey, you're going to play the flute today?
Oh God.
Okay, no, it's not going to work very well, okay? So I can come up with lots of different analogies here. We're going to stop there on those, okay? So we're going to substitute it in for what it is. So in this equation, y equals 2x plus 1. We see two different variables here. We see y and x. So we have this equation. We're saying if x equals 2, what is y? So we're saying if x equals 2. So what are we going to do with the 2?
Not 5.
What are we going to... Well, stop learning. What are we going to do with the 2? Plug it in for x. We're not going to plug it in for y. That'd be like putting the quarterback in for the O-line. That'd be putting like the defense specialist in for the outside hitter. We're not going to do that, okay? So x is going to be 2. So we're going to rewrite this equation. Okay, now when you make a substitution in a lineup, okay, is everything else changing normally? No, normally just that one thing changes, right? So the only thing changing here is x. So y stays the same, the equal sign stays the same, the 2 stays the same. The x is what's changing. Now, what was 2 doing with x before? Multiplying. So what's 2 going to do with 2? Multiply. So I'm going to put it in parentheses. Will that tell me I'm multiplying? Yeah. And then the plus is staying the same, and the 1 staying the same. So notice, everything stayed the same in this equation, except x was substituted for 2. 2 went in for x. Okay? Questions on how I got this blue equation? Okay, so now order of operation tells us what do I do first? Do I multiply or add? Multiply. What's 2 times 2? 4. What is 4 plus 1?
5.
So if x is 2, what is y? 5, and that's our answer. Now could I ask again, if x is a different number, what is y?
Yes.
Yeah, and you just start the process over again, wouldn't you? Okay? Questions on number 1. Okay, go ahead and try number 2. If y equals 3x minus 2, find y if x is 1. X is equal to 1, it's the same thing. We can substitute them for each other. So I rewrite this equation, and everything stays the same. Instead of 3 multiplying with x, 3 multiplies with 1. So what is 3 times 1?
Yes. 3.
But we still do 3 minus 2 now, so what's 3 minus 2? 1. So if x is 1, y is 1. So we put in x, we got out y. We put in 1, we got out 1 this time. We put in E4, we got out Butterfinger. Okay? Yes?
How did you get 1?
Great question. So notice how my first equation, does that make sense to you, Brady?
Yeah.
Okay. Do you see what you did now? Gucci. Okay. Is 4, 6 a solution to 3x plus y equals 30? What's that even mean, okay? Well, 4, 6, is that an ordered pair?
Yes.
Okay. So ordered pairs are written in what order? What, comma, what? X, comma, y. So is 4 secretly what variable? X. Y, and 6 is secretly? So could I plug 4 in somewhere to this equation? Where could I plug it in? Timesing the 3. So 3 times the 4. Where would the 6 go? For the y. Now, am I going to put the 6 in for the x? No, that'd be like the substitution. That's wrong. Okay, that'd be like putting my catcher at third base. Not going to do it. Okay? And we're going to say, does this equal 30? We're going to say 3 times 4 plus 6 equals 30, okay? What's 3 times 4? 12. What's 12 plus 6? 18. Is that 30? No. So is 4, 6 a solution to this? No, because it didn't work. Now what comes next though? Is 7, 9. So what would you do with 7, 9? Plug it in. Where does the 7 go?
Yeah, first.
The x. Where does the 9 go? the y. Okay, let's plug this in.
It's
3 times 7 plus what?
it's oh no.
9 equals 30. Okay, questions on how I got that pink equation? Nice. Okay. 3 times 7 is? Danny 1.
Wait, I'm actually understanding math.
Nice.
Same as.
Does Danny 1 plus 9 equal 30? Yeah, so 30 is 30. Okay, so is 7 comma 9 a solution? Yes.
Maybe I can
Okay. Questions on this?
Where do you think so?
What was that?
Oh, never mind.
Are you sure?
Yeah.
Okay.